Hi everyone, today's lesson is for 6 isosceles and equilateral triangles. And after this lesson, you'll be able to use the properties of both isosceles and equilateral triangles. So first of all, some vocabulary. We have the legs of isosceles triangle, and those are the two congruent sides. So in this case, leg 1 and leg 2 are congruent. The vertex is the angle made by those legs, so in this case, angle 1 is our vertex. And then the base angles are actually the ones that aren't the vertex, but they're the ones that are made up of the legs and then the base side of that of that triangle, isosceles triangle. So 2 theorems and 2 postulates for you to put in your notes. The first one is the isosceles triangle theorem, and it just basically says that if 2 sides of a triangle are congruent, then the sides opposite of those angles are also congruent. So that's the first one. And then the second one is the converse of the isosceles triangle theorem. So if we know that we have these 2 angles that are equal to each other, then the sides opposite of those 2 angles are also congruent. And then 2 corollaries to talk about in regards to an equilateral triangle. Equilateral triangles a triangle is equilateral if and only if it's equiangular. Equiangular is where all 3 angles are the same. And then each angle of an equilateral triangle measures 60 degrees, and that should make sense because there's 180 degrees in any triangle, and then if they're equal angular, 180 divided by 3 is 60. So let's take a look at our examples. Our first example here is we're going to name 2 unmarked congruent angles, and then we're going to name 2 unmarked congruent segments. So I'm going to start with the unmarked congruent angles. And as we take a look at this, we take a look at the diagram, and we're going to specifically look at triangle FGJ. And because we're told that FG is congruent to FJ, then we know or can say that angle FGJ is congruent to angle FJG. And why is that? Again, it's from one of those theorems that we just learned about. It's the isosceles triangle theorem. Okay, pretty straightforward. Now, in the second example, or example 1b, it says name 2 unmarked congruent segments. So as we take a look at our diagram, the key thing to key in here is we're given these congruent angles. And so again, now in this one, we're going to take a look at triangle GHI. And again, because we're told that angle HGJ is congruent to angle HJG, we know that sides GH is congruent to side HJ. Okay, and that's because of the converse isosceles triangle theorem. Again, very straightforward. All right, example 2. We're going to take a look at this diagram, and we have we need to find the measure of, or each measure. In 2A, we're going to find the measure of angle M, and in 2B, we're going to find the length of side PN. It's kind of hard to see, but we are given that angle P and angle M are congruent, so I'm just going to mark those angles a little bit more closely. So in 2A, we're going to find the measure of angle M. And so from here, we know that we have this triangle, and so we know that angle P plus angle M plus 120 has to equal 180 degrees. Again, the angles of a triangle add up to 180. And if I get rid of this 120, get rid of it, subtracting it, I know that angle P plus angle M has to equal 60 degrees. And we're told that these two angles are congruent. Well, in order for us to figure out what each of them equals, then we can just take 60 and divide it by 2 to get 30. And that's for both angle M and angle P. Again, that comes from that isosceles triangle theorem. Okay, in 2b, now we have to find the measure of side, or the length of side PN. In this diagram, we are told that MN is equal to 11 centimeters, and we know that PN is going to be congruent to MN, and that's because of the converse isosceles triangle theorem. Okay, so from here, then that must mean that the measure of PN is also equal to 11 centimeters. Okay, again, because these angles are congruent, then we know their sides opposite are also going to be congruent. Okay, let's move on to the last example. We want to find the value of each variable here. So the first thing that I'm going to do is actually find the value of y. And looking at this diagram, we are told that these two sides are congruent. So I'm going to set 4y minus 2 equal to 2y plus 2, and now I'm going to solve this algebraically. So I'm going to subtract 2y from both sides to get 2y minus 2 equals 2. I'm going to add 2 and divide by 2. So in this case, we find that the value of y is 2. Okay, and now I'm going to find what the value of x is. As we're looking at our diagram, again, because of the isosceles triangle theorem, and we have that these two sides are the same, then that means this angle in the corner and this angle given to us are also congruent. So to find the value of x, I know that 6x plus 8 plus 6x plus 8 plus plus 80 is equal to 180 degrees. Again, those are our three angles added up to 180 degrees. And again, we know that because of the isosceles triangle theorem that these two are going to be the same. So from here I'm going to combine terms. I've got 6x and 6x, 12x plus, and then 8, and 8 is 16, plus 80 is 96. And now again I'm going to solve it algebraically. So I've got 12x is equal to 84, and then I'm going to divide by 12, so the value of x is equal to 7. So we didn't really focus on anything about equal angular or equilateral triangles, so the main part of this is all about isosceles triangles.